Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome everybody again to another episode of our show, bringing you another really fascinating guest today, helping to create a better tomorrow on some really unique fronts. Today we have the honor of being joined by Dr. Ezinne Uzo-Okoro, who is Assistant Director for Space Policy at the Office of Science and Technology Policy at the White House, where she focuses on determining civil and commercial space priorities for the President's Science Advisor, and her portfolio is rather broad, including a wide range of disciplines, including orbital debris, Earth observations, space weather, planetary protection, as well as on-orbit servicing, assembly, and manufacturing technologies. Previously, Dr. Uzo-Okoro built and managed over 60 spacecraft missions and programs in her 17 years at NASA, in roles as an engineer, technical expert, manager, and executive in areas like Earth observation, planetary science, heliophysics, astrophysics, human exploration, and space communications. And these programs represented over $9 billion in total value. Her last role at NASA was as a heliophysics program executive. Dr. Uzo-Okoro has an undergraduate degree in computer science from Rensselaer Polytechnic, 3 master's degrees in space science, space robotics, and public policy from Johns Hopkins, MIT, and Harvard, respectively, and a Ph.D. in space systems from MIT on the robotic assembly of satellites. In addition to all that, she was involved in co-founding a group called Terraformers.com, focusing on growing affordable food through productive network backyard gardens. Is a very interesting precursor to growing food in space. And her story is also profiled in President George W. Bush's recent book, Out of Many One. A lot of interesting things to get into with her today. Dr. Ezinne Uzo-Okoro, thank you so much for taking time out of your schedule.
Thank you so much for having me.
It's really great having you. I mean, you have such an amazing background. I would love to start off, as we typically do, just by handing you the floor for a little bit to talk about how all this began. Your passions in STEM, for space, for all things the cosmos. Take us a little bit on that early journey, if you would.
That's a great question, because I think that the answer is usually not what is expected. I didn't know anything about space growing up. I just knew that I wanted to invent things. When I was 9 years old, I was always picking out problems, and I would write them down because I thought I could invent a solution. And so I studied computer science to learn how to invent things with software. And I ended up at NASA and used it as an opportunity to learn how to build things with no real world analog, because NASA still focuses on building unique spacecraft and unique rockets. I learned to be better at it by getting, an advanced degree in aerospace systems engineering. And then I realized, after building small spacecraft and large spacecraft, that, perhaps we should have robots build the satellites. Perhaps satellites are becoming, really more of a commodity, quite like cars. And so that was my foray into on-orbit robotic assembly. But it really started out as just a curious need to invent things and to fix the problems I saw all around me.
Excellent, excellent. And speaking along those lines, in terms of the theme, and this is really a core central theme to a lot of what you're doing, what you sort of have planned. When we look at your MIT thesis from a couple of years ago, entitled "Characterization of On-Orbit Robotic Assembly of Small Satellites," and in this is basically this theme, and we also see it in, and we'll get into sort of the national strategy for advanced manufacturing, but sort of this core theme that since the beginning of the space age, we've been making a lot of things down here, some small, some rather big, and shooting them up there. And a lot of what you're focusing on now on this principle of on-orbit assembly of what we can make up there. Some of this actually, in terms of your thesis, you've recently done some translation. I saw this really interesting article in the Journal of Small Satellites where you talk about the robotic assembly of some of these CubeSats and some of the successes that you've now had in translating these concepts. Talk a little bit more about the on-orbit servicing concept, if you would.
Of course. So, following on along the lines of having robots build these things for us, you could have robots build the satellites on the ground here on Earth, and then put them in rockets and put them in space. But then I thought, well, why not just go the extra step? Instead of conducting another incremental step, why not try to assemble the satellites in space on orbit first? And, in space is very broad. Space is very big, obviously. So start on orbit, an orbit close to us, like low Earth orbit, and maybe do it inside a locker. Maybe have a locker quite like, Amazon has these warehouses so close to us, and that's why you get things really frequently, right? So what if you had a locker in space that had all these satellite parts and the robot could pull the parts and assemble them and then launch the satellites on orbit. And then if it works, and that's why you start with small satellites, right? Because if it works with small satellites, then you could assemble large pieces of large components of satellites and make it bigger. So that was, what sent me to grad school. I was really passionate about that. And it's really great to kind of come full circle. You talked about advanced manufacturing, where we actually put out a policy on in-space servicing, assembly, and manufacturing, which is where I had the opportunity to expand on-orbit servicing and say, well, rather than just on-orbit servicing, on-orbit manufacturing, and on-orbit assembly, why not do it just in space? Because then you're catching all the communities who want to explore Mars and the technologies they need, the communities that want to explore the moon and the infrastructure and technologies that they need, the communities that care about low Earth orbit, so the remote sensing communities. Why don't we advance the technologies and elevate this sector through policy so that we could not just ensure U.S. leadership, but just continue to pioneer in scientific and technological innovation in this area. So that is, I think, the full circle of how I started off, interested in this topic in grad school. And it just made sense for us to prioritize it and prioritize the sector itself and create policy to accelerate commercial development of the technologies, to inspire the next generation, to ensure that we are providing expanding scalable key infrastructure, ensure that we are providing R&D, research and development, test beds, and opportunities for not just the government and commercial players, but also for academic researchers as well.
Excellent. Excellent. As in a couple weeks ago, we had Andrew Hebler on talking, a little bit about OSTP and specifically from the perspective of the life sciences and healthcare. You are specifically focused on this area of space policy. Could you walk us through a little bit about sort of the organization as it pertains to space, a little bit of where, because obviously, we've had different groups on the show, from NASA, from Space Force, from some of these other organizations that touch stuff up there. Talk a little bit about sort of where your directives come from, a little bit about what your day is like. Does the president come in and say, "Hey, I want you to think about this today"? How does it all work? What's your typical day like at the White House?
So first, we within the Office of Science and Technology Policy do three things. The first thing we do is to advise the president and others within the executive Office of the President on scientific, engineering, and technological issues. The second thing we do is we lead interagency science and technology policy coordination efforts. And that might be a mouthful, but what it really means is we ensure that the entire government is on the same page, that NOAA is talking to NASA, and we try to reduce redundancies. We try to make sure that ideas are being shared. And then the third thing we do is we serve as that source of scientific and technological analysis and judgment for the president with respect to major policies, plans, and programs of the federal government. And this spans the entire science and technology portfolio to advance health, prosperity, security, environmental quality, and justice for all Americans. And so when you think of the space portfolio, space lives within what we call the policy division. And the policy division has different elements that focus on broad-ranging policies. And space is one of them, because if you think of space and you think of other topics like AI, technology, energy, climate, national security, you can tie all of those to space. They're interdependencies. And so that's why we live in that policy division, because we touch on every other division. And so my portfolio varies, as you've mentioned. It typically covers civil and commercial space topics, not necessarily national security topics, even though we've got those dependencies. Topics like space weather, which includes, heliophysics, topics like microgravity research, and topics like Earth observations, which falls under climate and orbital debris, aeronautics, human exploration, and space science. So the best way, I think, to attack a day is to prioritize based on the administration's priorities, based on OSTP's priorities, some of which I shared with you. We're maximizing the benefits of science and technology. So once I prioritize what the administration is interested in space, what OSTP is interested in space, and then you really see, and then tie space to those topics, what you really see is a list of topics that we need to advance to continue to pioneer, to continue to maximize the benefits of science and technology. And so there could be some days where, missions to the Mars, Moon, and the Sun is included in a presidential speech. And, just to include that line, I work with a number of other policymakers on, because they want to verify, are there actually missions to the sun? Did we get that correctly? Because, not everyone is knowledgeable about all our missions. And then there are things like putting out policy, which we've touched on. So there's working on that convening of the interagency and ensuring that there is a crisp understanding of where we are all moving to together. And there are usually disagreements and, that we have to resolve. So that takes a lot of effort. And a third area is, not just future planning, but also how we engage in the present day with the American people like you, how we engage with youth, how we receive feedback from companies, or receive briefings from companies. And the overarching objective there is to ensure that, again, everything we are doing ends up with us leading, with US leading in space, with us supporting and promoting our commercial sector, and with us also supporting academia, the nonprofit sector, and others as we develop policies and plans. Some of these plans are also congressionally mandated. So we do have mandates that we have to include. The National Strategy for Advanced Manufacturing that you alluded to there is one that is congressionally mandated and needs to be updated every 4 years. So those are examples of things I spend my day on: speeches, policies, plans, and engagements. So one of the things also that I do day to day is plan some space events. So one of the space events that I planned recently that you may have seen was the historic release of the first image from the James Webb Space Telescope last July that the president released. And what was great about planning that event is it's not about me. It's about really ensuring that the people, the 20,000 people who worked on that telescope are acknowledged and thanked by the President of the United States, and that you all get to see the product of their hard work over 2 decades or more, because it is amplified at the presidential level. So that's one of the tasks I get to do daily that I very much appreciate.
Awesome. Awesome. And that segues perfectly into again we brought up the National Strategy for Advanced Manufacturing, which just came out recently, and there's this recommendation 1.4.4 in space manufacturing, and in this section, which I guess you wrote this all, developing new additive manufacturing process in microgravity environments to create replacement parts in space infrastructure. And then you go into biomanufacturing, sustainable food production, hazardous material deactivation. Is really a long list of really cool things, obviously, that we can do in this environment. Had some actually know some people that have sort of played around on the ISS doing some experiments in recent years. Talk a little bit about what went into sort of putting this section together, and a little bit about these different priorities within the in-space manufacturing component, because it's really quite broad and lays forth quite an impressive portfolio of what we potentially could be doing up there in the near future.
Yeah, so the great thing about a lot of the policies and plans and the process of developing them is to ensure coordination across all of them. So when you think of the in-space servicing, assembly, and manufacturing, we talk about building infrastructure. A space station is considered space infrastructure. So we want that to align with our advanced manufacturing plan, which is not a space document, but which is a manufacturing document. And what you see here then is a focus on manufacturing techniques and innovations that can be done on this planet by our manufacturing institutes, by our manufacturing companies, by our agencies that focus on manufacturing, and incremental steps that we can adopt in order to mature the technologies that are needed to ensure we have, improved space infrastructure, to ensure we have more innovative infrastructure in space and actually on the ground here as well.
And along the lines of the advanced manufacturing, which is something that you're very passionate about, you also are quite interested, rightly so, in the whole theme of space sustainability. I saw you were on a panel a couple months ago that was entitled "The Growing Need for Space Sustainability," and then satellite servicing role in that. And then also, I think I read that you were involved in crafting the White House National Orbital Debris Implementation Plan. Morba Jah joined us a few months ago talking about sort of there are technologies at Privateer to sort of track a lot of the stuff that's floating around up there right now. Talk about how space sustainability fits into all of this, because obviously we're going to be making a lot of things up there. we got to keep it clean, and we got to keep it sustainable for the long term. Take us into that area of your portfolio as well.
Yeah, so orbital debris is such a passionate and sensitive topic for a lot of people, and it's really an honor to have to work on it and try to shape it and move it forward. We all care about not just space sustainability, but also space safety. And I think that it is important for us to ensure that we are continuing to be good stewards and show responsible use of space through our actions. Last April, the Vice President announced a ban on anti-satellite missile tests, and we are, looking for the world to follow us in that example. So that's one example of ways that we are ensuring that we are showing, leadership and a responsible use of space. But then when you step back and look at orbital debris, it's not just, preventing the increase of debris that's important. Orbital debris can really be categorized into three. There is, how do you mitigate debris? How do you track debris? How do you remediate it? So that's, how do you recycle it? How do you repurpose debris? And obviously with mitigation, it's how we prevent debris in space by adding a lot of these technologies before launch onto the rockets or onto the satellites. And then tracking and characterization is more of how we use our modeling tools and simulation tools to ensure that we are finding new debris. How do we find more debris? How do we improve uncertainty? How do we improve the transition of research results into operational systems? And then the third category of debris, that remediation and repurposing, I think first we divide it into two, because you have to address small debris and then you have to address large debris.
Mm-hmm.
And active debris removal, if you're familiar with that term, is a subpart of this third group. And active debris removal is an exciting topic in space right now. It also falls under one of those topics that fits into multiple portfolio items, because for in-space servicing, for instance, or active debris removal is an example of that. It's because you would be removing, a sizable debris chunk or a component from an orbit, and you would need the similar technologies that you need for an orbit servicing to do this. And our goal was really to ensure that we developed implementation plans, because before this administration started, there was a national orbital debris research and development plan. We wanted to ensure that we had an implementation plans with actionable steps that each agency could take and play their own role in ensuring that we, again, were contributing to responsible behaviors in space. And I think that what we've seen is that there is a lot of interest and in the community, and a lot of excitement about the remediation piece, the tracking and characterization piece. We've got a lot of academic researchers helping us there. The mitigation piece, which is before launch, how do we create more designs to reduce fragmentation, to improve maneuverability? This also affects aviation and aeronautics. How do we conduct more research into shielding? So we've been doing work in all of these areas, and that resulted in this implementation plan that was released last July to, again, move us forward in ensuring that space is not only sustainable but safe.
It's completely fascinating. I mean, your portfolio is so impressive, and taking into account all these different dimensions of the picture. Um, what, as I mentioned in the intro, in addition to all of this that you have been thinking about and working on over the years, not just in your current role, but also at NASA, you also had time to create another venture known as Terraformers, which not the type of terraforming that we think about, sort of that they try to do in the Alien movies, but this one still really cool in the sense that you started with a pilot program in Lagos, Nigeria, looking at really productive and innovative ways to sort of network backyard gardening in sort of resilient, create new gardening systems on poor soils, ultimately to increase food production, but at the same time, start thinking about what you term sort of extreme environments, which potentially could have interesting applications, again, as we talk about not just hanging out in space, but producing food and thriving in space. Again, we talked a lot about some of these different stem cell food technologies on the show. We've done a little bit in terms of transgenic crops, making things, drought resistant and saline resistant and so forth. Talk a little just a bit about the background to terraformers and a little bit of the link that you see to ultimately how we sort of optimize for some of the really extreme environments that we're going to run into up there.
Wow, that was such a long time ago. I was focused on bioregenerative crops in space. And I thought, well, why not make food so ubiquitous on this planet that we become so good at growing it? And then we would be even better at growing it in space than we are now, or at the present time, at the time. And I think it's interesting, to watch this stem cell meats and the alternative meat companies. And the reason is because I love this culture of discovery. And I think that that's what's going on with them in the, bioregenerative systems, and their affiliated systems are important technologies because we are basically exploring what we will eat if we move to a foreign land, which is in space, right? That's what we're doing.
Mm-hmm.
And I think it's clear, we have to get to the fundamentals here. I think it's clear that we require nutrition. There are things that our body needs. In what form is questionable. But then it's clear that we still have molars. So let's discuss evolution a bit. We're not going to lose our molars anytime soon. So chewing is important.
Yep.
So you can't, if I put you on a yogurt diet or an ice cream diet, a soft diet or a liquid diet for a few months, you're going to want to chew something. But then the question is, how much crunch do you need? Does it need to be, and are soft chewables okay? Do you really need something crunchy? And there are people, thankfully, there are lots of researchers working on this. And that's why I think that this, as they are discovering, this culture of exploration will allow us to learn more about what food would look like in the future, not just in space, but here. When you think about the climate and how we are trying to be more responsible about what we consume. So, I love it. I think it's exciting. I don't know that we know for sure right now what we will be eating in 5 years in space. But when you listen to astronauts who have been at the International Space Station, especially the Europeans, when some of them complain about, the food, whether it's has a specific taste or doesn't have a specific taste. And then it really makes you think about what we really need, what will really satiate us when we move. You can't keep thinking of astronauts as Marines who will just eat anything that they are provided for the job, right? It has to be pleasurable. So it's one area to watch. I have to say, it just is one area to watch, because knowing our biology, knowing that we are not evolving, you know, out of our current form in the next century or so. You know, we do have to be judicious and think about what we will consume, how to package those things effectively and efficiently, how to grow them, and what form they will look like. And I'll give you another example to show how nuanced this problem is. I spent some time at the North Pole because I was fixing a polar orbiting satellite networks there, and so we were at the poles, and it's beautiful. It's just stark white, right? There's snow everywhere, and you know, you hear of this term Arctic beauty, and I thought, great, you know, white kitchens are in trend back home. I love the color white. It's fine. But after a while, you know, I grew tired of the brightness. I missed greenery. And I'm not someone who would say, oh, I must have, you know, 10 green plants in my office or in one room. But I missed it. And I think that, you know, we not only need this culture of exploration and discovery about what we will consume, but also what we will see and what we will look at when we think about really exploring our long-term stays somewhere else. So it's our systems really are so complex that we need to consider all of it for us to be successful. You know, because we are resilient and can do anything for a short amount of time. But if we are going to be successful and really become a multiplanetary species, then you have to consider all of that.
Absolutely. Absolutely. And that feeds perfectly into my next talking point, because the SpaceX Polaris Dawn programs, I think they're headed up at some point. I forget what the schedule is, but you know, one of the things that they're going to be they have a lot of research going on, but one of the areas that they're going to be looking at are, as you were just saying, resilience. Some of these extreme environment issues that we don't deal with, whether it's radiation, whether it's the microgravity, and you know, looking at the genomics and some of the other things that we have to, as you were just saying, take into account when we're going to be obviously we'll put the robots up there, but we're going to be up there as well. And so we have to deal with these things. They'll be studying something known as spaceflight associated neuroocular syndrome and other things I don't really quite understand. But any interesting sort of human resilience stuff that you discuss at OSTP? I mean, I know in the manufacturing plan, one of the things was sort of the biomanufacturing, and there's really cool stuff going on in terms of, you know, how regeneration occurs in microgravity compared to what happens when we're on the terrestrial side of things, and that's obviously very important for wound healing and so forth. Any interesting themes that you sit around thinking about on the sort of the human resilience / robustness front?
You know, this is such an interesting topic. You've covered a lot in just a small question. Let's start with biomanufacturing. You know, that is a very exciting area for us right now. There was a biomanufacturing executive order released recently for us to focus on this effort and ensure that we're developing. I think in the space section, we talked about developing biomanufacturing technologies for deep space, but we also think that we also believe that we need to advance biotechnology and biomanufacturing innovation for I think it's a sustainable, safe, and secure American bioeconomy. And what this executive order calls us to do is for a national approach to advancing biomanufacturing to provide these innovative solutions in different sectors, in health, in climate, and energy, and food security, and agriculture, and supply chain resilience that you mentioned, and national security, economic security. And so we outlined that in the plan. There are, domestic biomanufacturing capabilities and connecting the relevant infrastructure that we currently have, how we grow the biomanufacturing workforce, how we improve food safety. So what we are seeing is, we understand that manufacturing is essential to next generation medical therapies and devices that have these biological interfaces with both humans and animals. And so when you combine life sciences discoveries with advanced technologies, such as those in smart manufacturing, we can make these extensive leaps in the creation of these high quality bio-based products. Now, I want to go back to another interesting part of your question, which is the human health piece in long duration spaceflight. So we already know NASA has been looking at this. We have lots of universities and organizations that study this. There's one called the Human Resource Program. And so I would point you there for their up-to-date advancements in that research, because we unfortunately don't conduct research here within our office. We do try to maximize benefits of science and technology, as I mentioned. But I will talk to you about our goals in this area. And, microgravity research and development is an interesting term because it encompasses a bit more than that. And whether you call it low Earth orbit space research, human-tended research, microgravity research, we have to answer several questions at the policy level. I'll just rattle off some. Like, what is the United States vision for the future of microgravity research? What should the long-term microgravity research for U.S. presence in low Earth orbit be? What are the 3 critical research development or operational needs that are required to enable a seamless, smooth transition between microgravity platforms, because that's coming up, and help us realize the ideal future of microgravity research or space-based research? And what is the role of the U.S. government in this low Earth orbit space-based research and microgravity research after the retirement of the International Space Station? So we are trying to answer those questions. We leave the agencies to answer specific questions based on their research on human health in long duration flight. But I do want to expand a bit on what I mean by what we're looking at. We are looking at this, and I talked about the retirement of the International Space Station. What I mean by that is there's an anticipated conclusion of operations at the International Space Station. Right now, it's by 2030, and it is going to be a significant and visible transition for U.S.-led space cooperation. If you think about all the research that happens at the International Space Station from different countries, different agencies, different entities, U.S. leadership in managing, promoting, regulating, and increasingly capable space private sector as key aspects of this U.S. sustained domestic and international leadership in low Earth orbit is realized. And then the last thing I'll say about that and what we're thinking about is, we're thinking about the transition as a whole. We're thinking of considerations in as we anticipate the shift from a largely governmental system to largely commercial operators as a turning point for this research access and for processes, since the main source of funding for research and resources for microgravity, the main microgravity laboratory, for instance, may no longer come from the public sector. How do we ensure this seamless transition so that it ensures the continuation of ongoing research and the future of space exploration? So those are the questions we're trying to answer at this level. And here and there, I just love to get the briefings of where they are on on human-rated research.
Excellent. You know, speaking of the space station, I know that let's see, in June you were there was an article in Quartz magazine called "The U.S. Has a National Strategy to Put Factories in Space," and in this one, you basically talk about this sort of complete economy in the cislunar domain, so this area from the Earth out to around the moon and back. And you talk about some of the things in here in terms of the assembly of the satellites, the food production, but then you talk about new equatorial spaceports. And it's sort of just, I'd be interested in just sort of hearing your, big picture, as we talk about the CubeSats now, but sort of where is sort of in your dreams some of this sort of the cislunar domain is going, what it's going to look like maybe in the next 20, 30 years. And then I also noticed that the second part of this, sorry, another long question, but you do a lot of outreach, and one of the most recent ones I saw that you did, you gave a talk to the Girl Scouts of Greater Chicago, Northwest Indiana as well, talking about the future of the space economy. Just interested. I mean, I'm a very strong proponent, and I like to, hope that we have a lot of sort of the next generation listening to this show. But what are some of the things you're hearing from that next generation in terms of the STEM space thought leaders? And are you getting any interesting ideas from that next generation as you do your outreach?
Okay, so let me start with the second question first.
Sure.
You may have to repeat the first
Sure.
question. So it's always, invigorating to talk to the next generation. They are bright and full of optimism and ideas. And so I draw strength from them. And one thing I notice is they also want to build. They also want to know how they can contribute. And so my message is always the same. Hopefully it's not too redundant at this point, but it's actually been evident here in this conversation. Space is this multidisciplinary platform or phenomenon, really, where everyone can play. It's a place where the person interested in human research for long-term spaceflight can do work in a plethora of fields. It's space where someone who wants to build, someone who likes, welding and machining for fun, can also find a role for themselves in building the next generation space station, next generation infrastructure in space. We talked about cislunar space. We've got some activities on that in the office, but there just is so much going on, right? We talked about bioregenerative crops, and there are researchers looking at that. There's, that's basically agriculture in space.
Mm-hmm.
So whatever your passion, which is what I tell them, there is a place for you here. And it just excites me that they are beginning to see that, and they just want to know when they can dig in. And my question is always now, my answer is always now. Just go right ahead and stay curious what you're doing and find a way to contribute. So it's really a pleasure to speak to youth and draw strength from them.
Very good. Very good. What is thinking of sort of that term cislunar space, and obviously the one thing that comes to mind, because I'm a huge 2001 Space Odyssey fan, I sort of look at that image from 1969 as, wow, this is pretty cool cislunar stuff going on here. What are some of the sort of the fiction, sort of the movies, the shows, things that inspire you from sort of the Hollywood-ish folks that say, hey, you know what? It'd be cool to read Hollywood. That was a good perspective on that 50 years ago. We should recreate that. What are some of the, or don't you watch any sci-fi at all?
I'm not watching anything right now. The book that I've been thinking about a lot recently is Artemis, and it's not just because we have an Artemis program,
Mm-hmm.
but it's not even what they're doing; it's what they're eating in that book. This is blue algae. that
Mm-hmm.
they are consuming. And I wonder, does it have a crunch? Is it soft? Is it liquid? So that's what I think about in my spare time. I think that, I mean, you have to love The Martian.
Oh yeah.
Um, growing potatoes in space. One day we'll be able to do that, and that will be awesome. But I think that sci-fi books get us closer to where we want to be.
I agree. I agree with that. One other quick question while I have you. As I mentioned in your bio as an AI, that your last role prior to taking on this role at OSTP when you were at NASA was in the heliophysics group as a program executive. And I know you mentioned early on, sort of, we talked about going to the moon and Mars, but you also went to the sun. Any interesting sun stuff happening that, I see the sun come up every day, but I really think about headed back in that direction as much as what we hear about in terms of the moon and Mars. But any cool, interesting, fun fact related things to the sun that you can talk about?
Yes, I'll give you one technical answer, and then I'll give you a fun fact that just
Cool.
everyone needs to remember. The one technical thing is we are in what we call in heliophysics, we are experiencing some geomagnetic storms, and those are important because as some companies recently found out, sometimes if you don't maneuver your satellite during a geomagnetic storm, they can burn up and then you lose them. So we are in a period right now where we are experiencing a number of those. And then for the fun fact that everyone needs to remember, you can see a photo of the sun today, right now. If
Okay.
you go to sdo.gsfc.nasa.gov. SDO is Solar Dynamics Observatory, and it takes daily pictures of the sun. And so if you want to see what it looks like, a minute ago, like if you were close enough to take a picture with your phone, you could see it. And I think that's remarkable. And in addition to photos on the same website, you can see a short video of the sun up close. You can see volcanic eruptions, you can see flares. And I think that that's really cool because it's given how far away it is. The videos are not available daily. They have a delay of about 1 day because of
Okay.
process. But you can see that anytime. And I just think that everybody needs to remember that. Not just because it's one of the many innovative ways that NASA explores our solar system, but also because of the people who do that, the people you might never meet
Mm-hmm.
who work on heliophysics space missions, on astrophysics space missions, like the James Webb Space Telescope. There are just lots of different hardworking engineers who put their heads down and ensure that we have this science and technology for our benefit.
Isn't it? It's been really fascinating listening to you and seeing the scope of your portfolio and everything you're involved in, and just really, I wish you the best with all of this, rooting you on because it's just such an important area of not just scientific exploration, but as you point out, the continued development of our economy in terms of the space economy. For everybody that is going to be listening to this particular episode of our show across the various podcast networks or watching on the YouTube channel. Again, you've been listening to Dr. Ezinne Uzo-Okoro, Assistant Director for Space Policy, Office of Science and Technology Policy at the White House. Check out the Solar Observatory link. We will be putting that in the bio as well. Ezinne, I want to thank you for, again, taking the time out of your schedule to come talk to us and educate us for a little while on these topics. Obviously, thank you for everything that you're doing there at OSTP. And as we say on our show, thanks for helping to create a better tomorrow via all the work that you're doing. Really very impressive story.
Thank you. And thank you for having me.
Good to see you.